Welcome to part 3. Now that we have milled flat both of our pieces that we split in half on the vertical bandsaw, I will take note of the thickness of each piece with my 0 to 1 mics. And you see the thinner piece is going to be 145 thousandths. You have the 1, the dash, and then the 20. So the dashes are 25 thousandths, and then the 20 is 20 more, almost to the next dash. Not quite 150 thousandths, 145 thousandths. And now I'll measure up the thicker of the two pieces, and you're going to see later in the video why this is actually going to work out, why I actually don't need them to be the same size, how one being thicker is actually going to be helpful for what I'm trying to do here. So this thicker piece is 176 thousandths, 175 3 dash marks past the 1, and then 1 on the right dial. So just a hair past 175 thousandths, 176 thousandths. So what I have here is a 1/8 end mill, 1/8 of an inch thick, 1/8 of an inch thin, I should say, not very thick at all. And this will spin at a higher RPM than other end mills. A thicker end mill, let's say a 1/2 inch end mill, I might spin it at around 340 RPM, maybe 360 RPM, depending on the material. This one I'm going to be spinning over 400, maybe like 410, but around 400, just a little bit over. Maybe you could even go up closer to 500, honestly. And then we have a piece of stainless steel key stock, and you see it's stainless because my magnet is not grabbing it, so it is a little bit of a higher grade. Lower grades of stainless have a slight grab to them, and that 1/4 inch stainless steel key stock will come into play in the next video. But here we go. We have our thinner piece loaded up, and you see I wrote the number 47 in Sharpie. So I am aiming to go into the material 47 thousandths of an inch deep with the 1/8 inch end mill. So I touch the end mill to the material to get a baseline. I also check it with a level just to make sure the piece is sitting flat on the parallels, because I did mill that other side flat, so I just want to check just how flat did I get it. And sure enough, I got it very, very on the money with the setup you saw in part 2. So now I'm going in with the end mill. The end mill is going very fast. At this point, it's going right above 400, so that's why you're seeing the camera being a little distorted, because I did mount the phone right onto the vise. I'll have to have a different setup. Always trying to get that better setup for these as the next video comes out. But I'm going in all 47 thousandths, and on an 1/8 inch end mill going through aluminum, which could gum up real easily around the end mill, this could be not the best way to do it, and there could be some danger to coming soon, some impending doom. So I blow the chips out with the air gun, but then I keep going, and you see the chips are building up really fast in this small slot, this tight space around the 1/8 inch end mill. So you're going to want to blow the chips out much faster than I did here. But teachable moments, and we're going to showcase this on video, so prepare yourselves. The following video may shock you, may be too much for your eyes, but this is just a showcase. If you don't blow the chips well enough, fast enough, more often enough, this is what happens, and we're going to take a moment of memorandum for what's about to happen. So I was just showing you what not to do there with really small end mills like that. And I will hopefully never do that again, either by accident and definitely not on purpose. So it made a mark in my slot there that I was cutting, but I actually need to widen this slot out. And I'm not going to do that in this video. It's going to happen either in part 4 or part 5 once I get to that point. More on that later. So I will go to the next slot because these are going to end up being 4 separate pieces that I have already scribed vertical lines that you can see perpendicular to the vice jaws, and I will be cutting right on those lines. And I've given myself enough length to where I will actually face where I cut, because each piece is going to end up being 1.25 inches long, but the lines are 1 5/16 inches away from each other, so I can cut those with the vertical bandsaw, or actually I might even be able to use the horizontal bandsaw if I clamp another piece in that vise, and this piece way out on the end. But we'll get to that again later. So I'm milling out, being much more careful now with the other end of this 8-inch end mill, and this time I'm only taking 20 thousandths at a time per cut, especially because this is more of a enclosed cut that doesn't have an open end. It doesn't even have 2 open ends. I'm not going all the way through. So I'm going to just take 20 thousandths at a time on my way to 47 thousandths. That way I can ensure, with the air gun blowing the chips out way more frequently, almost during the entire cut, as I crank the table as slow and steadily as I can with my hand, because remember, there's no power feed, it's not working, so I have to do this manually. Old school, absolute manual control the whole way through with a very tiny end mill. Thankfully it's a 4 flute and not a 2 flute, so as I wind the end mill all the way back to my starting position, that way I clear up the pass that I just did to go for my next pass. Okay, so that looks good. I ended up doing all 4 sections. You can see there's a little space in between each section that I did not mill, because like I said, these are going to end up being 4 pieces, and I'm only milling all the way but not quite the whole 1 5/16 inches. And each right side of each slot is going to have that round shape to it, which I want, but the left side is going to match the first one with the opening, but I can only do the opening once I cut each piece off of each other. Then I can go back, go in with the end mill into that slot, do my opening, and then go to the next steps and beyond. So I'm laying out my scale over my other piece, the thicker piece, because I want to line up and match the rounded ends and scribe a line on the other piece to line up with those rounded ends. That way, I can just load that piece up into the vise, and everything's already set up for the exact 3/8 in or thereabouts for the end mill to mill a slot through the next piece. But I just want to know how far down the piece I'm going to go for each of the 4 slots. So I'll load the end mill back up into the 3/8 collet, like so. And you want to hold it all the way up in the collet so that you ensure it doesn't spin on you. And instead of laying the scale over my thicker piece and just leaving the first thinner piece in the vise, I decided to set up some parallels, 4 of them, so that I could lay the thicker piece up against the thinner piece and then clamp those down in the vise once I squared them up together. So I want the ends of them to be even Steven with each other. So I grabbed an 1 5/8 parallel, and I'm touching just the ends, the left side of both of my aluminum pieces, and I'll actually take the 1 5/8 parallel and not only touch it to the sides of both of my aluminum pieces, but also to one side of the vise. That way I know that the parallel is squared up, and then I can just push the aluminum pieces to the parallel that's already squared up, and therefore everything's squared up, just to get this dialed in as close and accurate as possible. You can see there's a slight gap here with the thicker aluminum piece, so I'll actually loosen the vise just a hair, and I'll tap that thicker piece over to the parallel so that I can ensure that both aluminum pieces are perfectly lined up with each other, or as close as I can get them with this whole manual setup. So now they're both lined up perfectly, and those 2 parallels in the middle, they're slightly different sizes than the ones on the ends, but I stacked parallels on top of each other so that all 4 sets of parallels add up to the same length, and they sit at the same height. And that is how I did that. So I'm going to clean off that little edge you see there, wipe it down with the rag, and I'll put the square up against that flat area on the outside of the vice jaw closer to you, closer in the screen, and I'll lay the scale across both pieces of aluminum. And because I'm squared up against the front side of the vice jaw, therefore I can just line up the scale with the previous vertical mark on the thinner piece and then just scribe my line down the further away part of the scale that's laid over the thicker piece that I'm trying to scribe a line on. And now all four lines, or sorry, I should say all three lines, are matched up on the thicker piece to the thinner piece. And these are not the long vertical lines. These are just lines that match up with the rounded parts. So I know where to end my slotted cut. And now here's where I'm doing the long vertical scribe marks, because these are the marks that will denote where I will cut the pieces into fours. But just to clarify, the first set of smaller length lines I did were to line up with the rounded parts on the thinner piece, so I know where to finish my slotted cut. And it's not going all the way through the material, it's just going down into the material enough for that stainless steel piece that I showed earlier in the video, but not all the way through. Okay, so here I'm touching the end mill down in between, because I had to reload the aluminum piece back into the vise after the vise got moved by, another coworker had to do something for an actual job. So of course I gotta, take my piece out and wait my turn, because this is not for an actual job. This is just for a video and for myself, personal project. So I put the end mill down in between, in the valley of my slot, and I'm running it down just slightly, not all the way down the length of the slot, but just enough to see if any chips are coming off, because that'll tell me if I'm towards the left or the right of the slot when I want to be in the middle. Like you see a few chips come off there, but I want to be in the middle of the slot. I don't want to take off any material on either side, so I want to line it up as best I can just by eyeball here. So that way when I run the end mill down, it's lined up perfectly with the slot, and then I can plunge down and come through some more. So I will not lock the table side to side, but I will lock it in and out. Just to clarify, I'm not locking the table left to right, but I am locking it forward and backward, because I want my slot to be perfectly straight. All four slots I'm going to do to be straight with each other, and I want all four slots to be straight with the other thinner piece 4 slots that I've already done, because these slots are going to be intended to match up with each other, and you will see that later on. I keep saying later on, but this is just one part of the process, and it's decently fairly involved, so a lot of steps here. So for this piece, it's my thicker piece, but in order to match up the slots with each other, match up the open end with the rounded closed end, this piece actually has to be flipped 180, so I can still do the slot in the same position that's 3/8 into the material, and therefore when they go to match up with each other later, they won't be on opposite sides, if you know what I'm saying. So I have my little scribe mark, but once there's chips flying and landing on the material, on the face of it, it's going to be hard to see that scribe mark, even with the flashlight. So that's why I'm putting a Sharpie mark directly behind the scribe mark, so I know to go to the very front of that Sharpie mark, but not any further, not into it, not past it, just to the very front of the Sharpie mark. Therefore, I know I can see it much better with my eyeballs, and that's where I know where to stop. There's, of course, no CNC machines to be found here in my shop around this channel, unfortunately, so I have to work with what I got. I'm sure I could set up some kind of indicator, like I've set up indicators on the lathe before, to know how deep to cut something, how far down the material to turn it before I can stop, write it, and set the dial on the indicator to 0. But here, this is the current setup. So now I have my 4 slots milled out on the thicker piece, and you can see they're all in line with each other because I locked the table from going in and out, and I actually had to upgrade the depth of my slot on each piece because I realized I can't mill down the stainless steel 1/4 inch piece as far as I was intending to. Of course, if we just had 1/8 inch stainless steel key stock in stock, I wouldn't have to go through all this trouble, but here we are. An extra step, but that's fine. So I'm actually gonna, from 47 thousandths, mill it down to 69 thousandths. So it's going to be just a little bit more, so I can take it all in one pass. And remember, don't go a full like 40 or more thousandths with the 1/8 inch end mill, especially if you're not blowing away the chips with compressed air like every other second. If you have coolant, you might be okay, but you still need to blow the chips out. Clear the chips out of the path of the end mill so they don't gum up around the end mill. That is a very important thing to keep in mind. And of course, I did learn that in year 1 and 2, but here we go in year 6. I'm just trying to get through it faster, but sometimes you just gotta take it slow and get it done right and not break any of your tools. So I plunged down with my calipers just to check the depth and to ensure I was 69 thousandths deep. And I was just a hair over, actually. I think it was more like 72 thousandths deep. But that should be okay to give a little clearance for that stainless steel piece once I insert it into there later. So here, my 2 drilled holes, I just picked 2 ambiguous spots on the piece because these are dead zones, which I will actually mill out later. But I figured out at this point in the project, the thinner piece and the thicker piece of aluminum, I actually want to bolt together. But these 2 holes do not line up with the holes on the thicker piece of aluminum. And those slots I actually milled out to 99 thousandths, and this is 69 thousandths on the 4 milled slots on the thinner piece here. If I did not, and I did not mention that already, which is why I wanted to mention it now. So I'm milling out the slots, the drilled and tapped hole, because I want to make it a through hole on the thinner piece, and I want to keep drilled and tapped holes on the thicker piece. And the reason that I'm glad that these 2 pieces are different thicknesses is because the thicker piece will have the 4 drilled and tapped holes eventually, but I'll leave those drilled and tapped because there's more threads that I cut with my 1/4 inch tap. And yes, I know someone already gave me grief on the part 2 video for using a crescent wrench and an adjustable wrench for tapping, but I was holding the tap perfectly straight with my piece that I machined and then chucked into the drill truck that was in the mill. So I'm making my other through hole here on the thinner piece of aluminum. And I'm just going in with a 1/4 inch drill because I want this hole, which is already lined up pretty well, almost right on the money with the thicker piece of aluminum with the tapped hole. I just want to do a 1/4 inch hole because the other piece with the drilled and tapped 1/4 inch hole they're both to each other be very lined up. And once I put that bolt through, there won't be a lot of play, and that'll help me line up the 2 pieces together from a starting standpoint. And that way I won't have to shift them around so much just to get them lined up with each other. And you'll see later I actually use the vise to help me further line them up. And that'll work out for me pretty good. So on the back side, because the 2 mill faces of the 2 aluminum pieces, they're going to get bolted together. So I'm going to want to make sure I run a countersink with my Milwaukee drill through each hole that has a burr sticking up out of the material. Because of course, if I bolt them both together and they have burrs sticking out towards each other, then both pieces aren't going to sit perfectly flat against each other once I bolt them together. They'll be slightly off kilter and raised up, and they won't be sitting perfectly flat, and that is not the goal here. So I found some 1/4 inch bolts, 3/4 inch long. I found a lock washer and 2 flats, because what I need to do is I need to put the bolt in, but I don't want it to stick out the other side. I want it to be flush or slightly recessed back from sticking out through the tapped hole on the thicker piece of aluminum. And you see there, my big hole that I slotted out with the 3/16 end mill, it's not quite lined up with my drilled and tapped hole. So what I'm going to have to do, or what I've eventually figured out, is I have to actually take these pieces back apart, because I bolted them together just to try to see if they were both lined up with each other on all four sides. But unfortunately, they were lengthwise, they were sticking out slightly off from each other if you looked on the right end. Top and bottom right here, it's good. They're good lined up that way. But the top thinner piece actually had to shift over slightly more to the left to line up with the bottom thicker piece on that bigger hole that I used the end mill to notch out. So I actually had to notch it out a little bit more, so I just ran a Sharpie around the top left side of that notched out hole, so just so I know how much more I need to notch it out with that 3/16 end mill. And that's what I'm going to do here to ensure that when I put the bolt down in the hole, the bolt is not going to force the material over, because that's where the bolt needs to go, towards that top left section of the hole. And there will be some more, I'll just wallow out the hole a little bit more, so that way my bolt can freely pass through the hole and not be touching any sides, and then thread directly in to the hole underneath it that's tapped, which is part of the thicker aluminum piece. So these are just the two holes, and I figured I would go ahead and bolt them together. And once I bolt them together, then I could do the other two holes without worrying about the two pieces shifting off of each other. They will stay lined up with each other. And that was the whole intent here by doing this whole process. Because I could take one piece, put it in the vise, in the milling machine, one at a time, drill all four holes, and then try to put the other piece in and try to line it up as best I can. But I figured, why not just drill them in the same setting? And yes, I could probably get away with just without these bolts and these tapped holes and grabbing just the two pieces in the vise by themselves. But every once in a while, I find that when you try to bolt, or you try to grab two pieces in the vise that are the same size, you're drilling through both of them, sometimes one is slightly looser in the vise. The vise doesn't seem to grab both perfectly and equally with the same amount of force. So that's why I figured for this purpose, and I don't have any more of this aluminum stock in this size, so I really have to be critical with every step, and I don't want to have a chance of anything messing up, which is why I'm going this extra step to bolt these two pieces together instead of just relying on the vise, clamping them both together, and just, hopefully things work out. I want to go the extra step and show it on video to show you guys that if you bolt two pieces together and then clamp them in the vise, it's really, really much more secure, and you really don't have to worry about it. Yes, it's going to take more time, but if you have the time, take the time and just have that extra step so you can have that extra assurance, that extra peace of mind that it's going to work out. And I just take my soft hammer and I smack the top. I could smack it on the bolts since they're sticking up, and I smack the material down against the parallels. That way the parallels aren't just shifting freely to the left and right underneath the material. The material's more, you kind of have to push the material down by smacking it with the soft hammer. That way, because every time you grab the material in the vise, it doesn't quite have the material sit perfectly on the parallels. So you actually have to smack it down with a hammer against the parallels so everything sits flat and the parallels are kind of pushed down into the bottom area of the vise. And once you do that, everything's squared up, everything's flat, and then you can go at it. Especially if you're going to mill something across with an end mill, try to mill something flat on the top side of the material. You want to make sure the material's sitting flat against the parallels, and the parallels are flat against the bottom area in the vise. That way everything's squared up, and whatever you mill on the top is going to be flat to the bottom and true to each other. So now here, I already had some scribe marks and a punch mark, and so I line up with my little countersink, the tip of it, to the punch mark, and that way I can go ahead and go through with my center drill and then go through with my number 7 drill, a 201,000ths of an inch thick. And once I do that, I can touch the countersink down in that number 7 drill hole to have a little starting countersink area for the tap to line up with that. And what I'm going to do here is, because the top piece is going to be all through holes, I very, very carefully take it out of the vise and be sure not to move the bottom piece, because I'm going to want to quickly tighten the vise right back up, run my countersink into the bottom thicker piece, because that's the piece that's about to be tapped for a 1/4 20-inch hole. And I also run the countersink through it, of course, because once I bolt the two pieces back together, I want them to not have any burrs between the two milled off sections that we did with the fly cutter in part 2 in the last video. So again, roast me for using a 6-inch adjustable to tap the hole, but it works. It just works. Yes, it may not be how the machinist gods intended, or however you learned it, but I have my piece chucked up in the drill chuck, and I'm putting slight pressure down on the tap, and with my other hand I'm running the tap down, and the tap's got 4 flats on it. So what do you want from me? It works, and I'm just going through aluminum. And if you have a better suggestion, don't just yell at me to stop using a Chris wrench, and don't call me a barbarian. Still call me a barbarian, call me whatever you want, but at least provide some constructive criticism or your advice in the comments section. Unless you're just fooling around, then that's fine. Fool around in the comments. But I'm just saying, I had to call attention to it because I got a comment about it. Okay, so we'll blow the chips out. We'll lay our thinner piece back on top. And I won't do the through hole, the 1/4-inch through hole in the number 7 hole just yet. I'm going to tighten everything back up with my 2 bolts, making sure the left and right sides are lined up with each other. And then I'll tighten the vise to clamp my piece back in. And I'm going to do the 4th hole with the number 7 drill through. And then I'll take this piece back out. That way I can tap the 4th 1/4-inch hole in the same setting as I did the number 7 through hole. So that way everything will be lined up with each other. And then once all 8 holes are lined up with each other, then I can go back into the thinner piece of aluminum and do my 1/4-inch through hole. Always make sure when you're going through 2 pieces of material and you want your holes to be lined up, do them in the same setting before you start to move on to the next step. The next step is going to be the 1/4-inch through hole, not before what you're seeing right here. Okay, so now we have all 4 holes tapped, and we're getting close to the end of the video. So if you stuck with me so far, thank you very much. Drop me a subscribe, drop me a like, whatever you want to do. We're trying to get to, let's say, 555 subscribers by summertime, but it already feels like summertime. It's like 88 degrees out today. I was working in Rockville and elsewhere. Did I dox myself? Possibly a little bit, but there's so many millions of people around here. So I'll take both pieces out, and I will go ahead and put my thinner piece back in, but I keep it slightly loose in the vise, and I take the countersink and I touch it to the hole that I'm going to be drilling through. And the countersink, because it has 3 sides that are nice and even up with each other at 82 degrees, it's actually going to pull the material in, center it up, the hole with the countersink. And then I can go through with my 1/4-inch drill to make the through hole, and then come in with the countersink, because remember, this is the milled off side, which is going to be bolted to the other milled off side with the thicker piece. And I'll go around to the other side of the thin piece here, and I will, again, run the countersink in to line up the piece left and right, and that way I don't have to worry about the countersink being slightly off center from the hole that I have drilled, and that way everything looks nice and neat and precise. So these 4 holes, like I said, they're in areas that will be milled out later, but if I milled them out sooner, I would not have been able to do these processes in terms of fixturing, and it would have not, milling these out as a first step would have really, been a shoot myself in the foot, because this is so helpful for keeping things lined up. If you have dead space in your material that you're going to mill out later, don't necessarily mill it out right away. Mill it out more towards the end because you might have a use for that dead space, which I'm showcasing here. So I got my 2 bolts from earlier. Those still line up. Everything's lined up on the left and right sides. And then I'll put in my other 2 bolts. And now the piece is very secure. This may be overkill, 4 1/4" 20 bolts into 2 pieces of aluminum, but I'm here for it. I'm going to tighten each one evenly as we go along. And thank you very much for watching part 3. This has been securing the 2 pieces of aluminum to each other. We milled out the 4 slots, but we're not quite done with the slots because we need an open end on each left side of each slot. But I wanted to make sure the 4 slots in each of the 2 aluminum pieces were lined up with each other, which you are about to see when I pan the camera over to the left side, looking down through the vise. And then I can work on cutting each piece into 4s so that each piece will become its own. And then we'll move on to the next video because this process that I'm doing needs to be done by next week before I leave on my trip to Houston. So as you can see, both eighth inch milled slots are lined up with each other, but they're going to be widened out to a little bit more than 1/8 inch, but not quite 3/16. So stay tuned for the next video. Thank you very much for watching. See you later.